Hello everyone, welcome to lesson 5 in math. It's square roots and basic exponents, and today we will learn to solve square roots and basic exponents, and at the end we will also compare exponents. So part 1 needs square roots of perfect squares, and just as a reminder, this is a square root symbol or sign, and perfect squares are numbers that we can square. So for example, the square root of 1 is 1, because 1 to the power of 2 is 1. The square root of 4 is 2, because 2 to the power of 2 is 4. The square root of 9 is 3 because 3 to the power of 2 is 9. And the square root of 225, for example, is 15 because 15 to the power of 2 is 225. Here are some practice questions for you. And for the last one, it's kind of a switch. So I've already given you the square root. You have to find the number that is going inside of the square root sign. Part 1b, estimating square roots. So for square roots that are not the square roots of perfect squares, we estimate. So for example, the square root of 10, there is nothing. So like nothing squared will give 10. Therefore, we have to make an estimation. And here are the steps that you take to estimate square roots. First, you have to find the perfect squares closest to the approximate square root, and you have to mark them as the endpoints on the number line. So this tells you that we're using a number line. Then you have to find the mean between the perfect squares, and we talked about mean in lesson 1. And finally, you have to recognize which perfect square root the approximate square root is closest to and find the mean between that perfect square root and the mean you found in step 2. So we're going to be doing some examples so that you better understand what these steps mean. I know they're kind of wordy right now, but they're pretty easy. So let's start with this example. So estimate the square root of 40 on the number line below. So here I already have all my numbers, but let's pretend that they're not there. So let's start with step 1. Find the perfect squares close to the approximate square root and mark them as the endpoints on the number line. So for 40, like I said, there's nothing that if we square it will give us 40. But two numbers that are closer, or the closest to 40, that are square roots, could be 36 and 49. So for example, the square root of 36 is 6 because 6 to the power of 2 is 36. And 49 is another one that's closest to 40 because the square root of 49 is 7. And this works out perfectly because you have 6 and you have 7, and they go at the endpoints on the number line. Next, we have to find the mean between these perfect square roots. So that means for 49 and 36. So 36 plus 49 is 85, and you have to divide that by 2 to get approximately 42 and a half, or 42.5. And that's going to mark halfway of our number line. It's not always going to mark halfway. In this case, it does, because if you square root 42 and a half, it works out perfectly and gives us 6.5. But for step 2, whatever you do in step 2, it's not always going to give you the middle point of the number line. Now, we're moving on to step 3, and we have to find out or recognize which perfect square root, the approximate square root, which is 40, is closest to. So 40, is it closest to, if we were marking 42.5 in the middle, is 40 closest to 36, or is it closer to 49? And if 42.5 is in the middle, well, it's logical that 40 would be closer to 36 if 42.5 is in the middle. So it's going to be more to the left. Now we have to find the mean between that perfect square root, which is 36, and the mean we found in step 2, which was 42 and a half. So doing that, 42 and a half plus 36 is 78.5, and dividing that by 2 gives us approximately 40. And when we find the square root of 40, it gives us 6.3, and this all works out perfectly. So just as a quick review on what we just did, basically we first found the two perfect squares that were closest to 40. So that was 49 and 36. We found the mean by adding them and dividing them by 2, and we got 42.5. We were finding the square root of 42.5, and that was 6.5. Then we realized that 40 would be closest to 36, and so we took 36, we added it to 42.5 to get 78.5, and divided it by 2 because we're working with mean, and there are two numbers. So we divided by 2, and we got 39.25, which basically is approximately 40. And this is a correct answer, and that's how you would check your work. So remember, we're estimating square roots. It's not going to be a perfect square, so it's going to be an estimate, and this is correct. And so now we're going to have some practice questions. There are two, but I'm going to do the first one for you or with you. So we're going to estimate the whole number that has a square root 2/3 of the way along this number line. So when you're given a question like this, you're also given some numbers on the number line. It's not going to be blank like this. And basically, in this case, we would be given square root of 9, which is 3, square root of 16, which is 4. So we know our endpoints. And from there, you can, and also we're given which 2/3 of the way on the number line we have to look for. So in this case, 2/3 of the way would be somewhere around here, and this is what we're finding for. So basically, now that we're given the data here, we can skip step 1 and start with step 2, which is finding the mean between the perfect square roots. So that means that 16 plus 9, and that's 25, divided by 2 is 12.5. And if we square root that, we're going to get approximately 3.5. So 3.5 squared is about 12.5. Okay, so that's the first part. And then we're going to mark that in the middle of our number line because it's 3.5. 3.5 is going to go right in the middle from 3 and 4. And then above that is going to be approximately 12.5. Now we're going to figure out, okay, so 2/3 of the way, which is all right here, we don't need to figure out where it's closest to. You can literally see that it's closest to 16 as opposed to 9. So we're going to be working with 16. So 16 plus 12.5 is 28.5. 28.5 divided by 2 is 14.25, which is approximately 14. So therefore, the estimated whole number that has a square root 2/3 of the way along the number line is approximately 14. And how do we check our answer? Well, the square root of 14 is about 3.74, which is about the same thing as 3.75 or 3/4. And now we know that our answer is correct. So try number 2 by yourself. I will have the answer in the description box, but this is more, it's an easier question. It's not like question 1. It's more like question, or this example we did. So if you want to stop there with square roots, then that's fine. But if you want to give yourself a further challenge or you want to learn about exponents, then we'll move on to part 2. So part 2 is understanding exponents. Exponents can be any number, so like 2, 3, 4, 6, 10, 17, like whatever. It's going to be that small number above the base. And it does not mean that you are multiplying the base by the exponent. Students tend to get confused with that. They think that, for example, if it's 4 to the power of 2, that means 4 times 2. But no, that's incorrect. That basically means that 4, which is the base, and 2, that is the exponent, so 4 is going to be multiplied by itself twice. So 4 times 4, which is 16. It does not mean that 4 is multiplied by 2. So here I have some practice questions for you. The first part you're going to expand. So what I did here, for example, if it's 8 to the power of 2, you're going to do 8 times 8, and then you're going to put your final answer here. Part 2b, comparing exponents. So that's when we're basically saying, is it greater than, less than, stuff like that. So say we have something like 5 to the power of 4 versus 4 to the power of 5. You're gonna want to show your work because, I mean, personally, I'm a visual learner, so I like to see all the numbers in front of me. But if you could do it in your head, then that's awesome. But when you get to, multiplying numbers that give you a product like 1024, you might make a mistake or something. But basically, for this teaching purpose, I've put them here. I've written them. So 5 to the power of 4 versus 4 to the power of 5. For 5, you're obviously going to multiply 5 by itself 4 times. And that's going to be 625. And for 4, you're going to multiply by itself 5 times. And that's going to give you 1024. So now which number is bigger, 625 or 1024? That's obviously 1024. So 5 to the power of 4 is less than 4 to the power of 5. Next is 9 to the power of 5 versus 5 to the power of 9. So we're going to take 9 multiplied by itself 5 times. It's going to be 59,049. And we're going to take 5 multiplied by itself 9 times, and it's going to be 1,953,125. And so which one's bigger? Obviously the second one. So 9 to the power of 5 is less than 5 to the power of 9. And finally, 3 to the power of 6 versus 6 to the power of 3. So we're going to take 3 multiplied by itself 6 times, and it's going to give us 729. We're going to take 6 multiplied by itself 3 times, and that's going to be 216. So which one's bigger? It's obviously 3 to the power of 6. So 3 to the power of 6 is greater than 6 to the power of 3. And here are some opportunities for you to practice comparing exponents. I'll put the answers to these in the description box. You can show your work as well and then put the final answer because it's going to help you. But like I said earlier, if you're good with doing this mentally, as in mental math and imagining all the numbers in your head, then that's perfect as well. Okay, so thank you so much for watching this video. Hopefully you were able to better understand square roots and basic exponents. And we're going to be working with exponents a lot and square roots in future lessons, so stay tuned for those as well. But thank you for watching this video, and see you in the next one.